One of the most popular Python data science libraries, Scrappy, helps to build crawling programs, spider bots that can retrieve structured data from web, for example, URLs or contact info. It's a great tool for scraping data used in, for example, Python machine learning models. Developers use it for gathering data from APIs. These full-fledged frameworks follows the don't repeat yourself principle. In the design of its interface, as a result, the tool inspires users to write universal code that can be reused for building and scaling large crawlers. The second one in this group is Beautiful Soap. Beautiful Soap is another really popular library for web crawling and data scraping. If you want to collect data that's available on some website or not via a proper CSV or API, Beautiful Soap can help you scrape it and arrange it into the format you need. Next thing is data processing and modeling. For this, we will use NumPy. This is very useful for mathematical works. Okay, so NumPy, full name is Numerical Python, is a perfect tool for scientific computing and performing basic and advanced array operations. The library offers many handy features, performing operations on an array and matrices in Python. It helps to process arrays that store values of the same data type and makes performing math operation on arrays and their vectorization easier. In fact, the vectorization of mathematical operation on the NumPy array type increases performance and accelerates the execution time. The next one is SciPy. Let's see what it offers. This useful library includes modules for linear algebra, integration, optimization, and statistics. Its main functionality was built upon NumPy, which we have seen before, this one, NumPy. So its array make use of this library. SciPy works great for all kind of scientific programming projects, sciences, mathematics, and engineering. It offers efficient numerical routines such as numerical optimization, integration, and other submodules. The extensive documentation makes working with this library really easy. So this is the fun part. Next one is Pandas. Pandas is a library created to help developers work with labeled and rational data intuitively. It's based on two main data structures. First one is series, which is one-dimensional, like a list of items, and data frames, which is two-dimensional, like a table with multiple columns. Pandas allows converting data structures to data frame objects, handling missing data, and adding, deleting columns from data frame, importing missing files, and plotting data with histogram or plot box. So you'll have a plot box there, remember that. It's a must-have for data wrangling, manipulation, and visualization. Well, let's go to the next one. Keras. Keras. Okay. So Keras is a great library for building neural networks and modeling. So if you guys want to build a neural network, I think you should use this one. It's a very straightforward to use and provides developer with a good degree of extensibility. The library takes advantage of other packages. Theano or TensorFlow as its backends. Moreover, Microsoft integrated CNTK. It means Microsoft Cognitive Toolkit to serve another backend. It's a great pick if you want to experiment quickly using compact systems. The minimalist approach to design really pays off. Okay, next one, scikit-learn. This is an industry standard for data science project based in Python. Scikit is a group of packages in the SciPy stack that were created for specific functionalities. For example, image processing. Scikit-learn uses the math operations of SciPy to expose the concise interface to the most common machine learning algorithms. Data scientists use it for handling standard machine learning and data mining tasks such as clustering, regression, model selection, dimensional reduction, and classification. And other advantage? Well, it comes with quality documentation and offers high performance. That's pretty impressive. Next one is PyTorch. PyTorch is a framework that is perfect for data scientists who wants to perform deep learning tasks easily. The tool allows performing tensor computation with GPU acceleration. See, this PyTorch has GPU acceleration feature, which is pretty amazing. It's also used for other tasks. For example, for creating dynamic computational graphs and calculating gradients automatically. PyTorch is based on Torch, which is an open source deep learning library implemented in C, with a wrapper in Lua. The next one is TensorFlow. TensorFlow is a popular Python framework for machine learning and deep learning, which was developed at Google Brain. Let's see what is Google Brain, right? Let's check this out. What is Google Brain? Okay, Google Brain. I'm searching it on Copilot. Let's see what it says. Okay, what is Google Brain? Google Brain was a deep learning artificial intelligence research term at Google, part of Google AI. It was formed in 2011 and focused on combining machine learning research with large-scale computing resources. Good, now we know what is Google Brain. It's the best tool for tasks like object identification, speech recognition, and many others. It helps in working with artificial neural networks that need to handle multiple datasets. The library includes various layer helper, which make it even more functional. TensorFlow is constantly expanded with its new releases, including fixes in potential security vulnerabilities, improvements in integration, and TensorFlow and GPU. The next one is XGBoost. It is also used on data processing and modeling. Use this library to implement machine learning algorithms under the gradient boosting frameworks. XGBoost is portable, flexible, and efficient. It offers parallel tree boosting that help teams to resolve many data science problems. Another advantage is that developers can run the same code on major distributed environments such as Hadoop, SGA, and MPI. So we have 5 more stuffs here which is used for data visualization. One is matplotlib. Interesting name. Okay. This is a standard data science library that helps to generate data visualization such as two-dimensional diagrams and graphs, histograms, scatter plots, non-Cartesians, of course, non-Cartesian coordinate graphs. Did you do the Cartesian maths in past? If you had, then you are familiar with this term. Matplotlib is one of those plotting libraries that are really useful in data science. Blah 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 blah. I'm not gonna read this. Next one is Seaborn. Seaborn is based on matplotlib and serves as a useful Python machine learning tool for visualizing statistic models. Okay, that's done. Next one is Bouquet. Okay, more interesting this name is. This library is a great tool for creating interactive and scalable visualization inside browsers using JavaScript widgets. Bouquet is fully independent matplotlib. Alrighty, let's go to the next one. Plotly, this web-based tool for data visualization that offers many useful out-of-box graphics. So for out-of-box graphics, you should use this guy. You can't find them on the Plotly website, of course. The library works very well in blah blah blah. Those are just description. I'm skipping it. PyDot. This library helps to generate oriented and non-oriented graphs. So if you're familiar with what is oriented and what is non-oriented graphs, then I think you will need to work with this for making those. It serves as an interface to GraphViz written in pure Python. You can easily show the structure of graphs with the help of this library. We already know that because it is oriented and non-oriented graph based. So, okay, that comes in handy when you're developing algorithms based on neural networks and decision trees. Okay, this one is important. So it is really handy when you are developing algorithms based on neural networks and decision trees. So recently there are many people who are working on neural networks. If you are developing an algorithm based on this, then use this one. So guys, that's all. Hopefully it will be useful for you at your education. And next time I will try to come up with some other videos. Have a great day.